In this lesson, we'll see how to describe a graph. A graph is usually a representation of a set of data, and our set is going to be visual, so it's going to be a set of figures that we're going to notice what the pattern is from figure to figure, and then how to notice a pattern, how to describe it, how to graph it, and describe a graph. So a few questions to consider. When we have a set of data, what is the pattern? So we'll try to notice a certain pattern. And then how can we describe the pattern if we notice it? How does it grow? Or sometimes, how does it get smaller? So the pattern can be going from a bigger figure towards smaller, smaller, smaller. Or how can we organize the data? So the organization can be in the chart, it can be in various ways. So I'm going to be using a chart today. So for this activity, we are going to study the pattern from original given figure to the next, to the next, to the next. Given the 3 squares for the original figure, we have those 3, and then noticing that there are 2 on top, on the bottom, and 1 goes onto the side. So that would be 5 squares. Then the next figure is the previous. So the previous I shaded in green, and then the increase I am shading in orange. So that would be those 5 squares added to the next previous figure, and then 5 squares added to the next. So we have 3 in the first, then plus 5 should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Then plus 5 should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then plus 5, and so on. Every figure will be 5 tiles larger. So that is the pattern. A way to organize your data is to create the chart. So I'm going to complete the table of values. Starting with figure 0, I'm going to record how many tiles was in figure 0. Then the first figure, or the one after, was 8, so that means 5 tiles more. Then the second, or figure number 2, labeled, was 13, which is growth again by 5. And then figure number 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which is 13 plus 5. So we're noticing the growth from figure to figure, adding 5 tiles. So the fourth then should be 23 tiles, because following the same pattern, we're going to add 5. Fifth figure will be 28. And so on. So this chart can be very, very big if I was to just add 5, 5, 5, 5. And my question is, okay, how many tiles will be in figure 50? Or figure number 70? Or figure number 92? So we're not going to extend this chart, but we're going to use this pattern to come up with an equation that works for every figure to determine the number of tiles. So following the pattern allows us to create an equation to find the number of tiles in any figure. But we'll get there one step at a time. So first, how can we describe this pattern? So I'm going to say, instead of just showing that I have plus, 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 plus 5, I'm actually using a sentence that the number of tiles grows or increases So increases or grows by 5 from figure to figure. So that is my observation of how the pattern grows. Then I'm going to use this chart to create a graph. So I'm using the border of my page for the y-axis, and then one line I'll trace here on the bottom for the x-axis, because it is a big graph and the numbers grow, and I'm going to use a lot of space. So I'll just put a few numbers to see the growth, not all of them, and observe what kind of graph will be represented by this set of data. So what I'm going to have again is on the x-axis, the figure. So my x will be represented by the figure number. So I have from 0, 1, 2, 3, 4, 5. And then for the y-axis, it's going to be the number of tiles used. So my figure labeled 0 had 3 tiles, so that is 0, 3. That's the starting point. That is the first figure in the pattern. Then the first figure had 5 more tiles, and in the chart I have for the 1, y is 8. So x is 1, y is 8. So first figure, 8 tiles. 1, 2, 3, 4, 5, 6, 7, 8. And then for the second figure, I have 13. So 2, 13 would be the ordered pair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see, I can do another one. That would be 3, 18. So for 3, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then for the next one, instead of counting all the way, I'm going to just increase that 5 by 1, 5 by 1 ratio or the slope. So from the previous figure, watch, I have from 3, 5 by 1. That was for the next figure, I had to add 5 tiles. Then from the previous one, I go again 5 tiles to get to the next. From that one, I had to add 5 to get to the next. So from this one, I'll have to add 1, 2, 3, 4, 5 to get to the next. So that is our slope or the ratio, 5 tiles per figure. 5 tiles per figure. And if I use a ruler, let me use this yellow side so it's more pronounced, you can see that ratio. For the figure that we have, we increase 5 tiles. For the next figure that we have, we increase 5 tiles. For the next one, 5. For the next one, 5. So that consistent pattern by adding 5 tiles per figure creates this linear equation. It is a line. I'm going to have a dashed line just showing that it will follow a linear growth, but I'm not tracing a straight line because it's a discrete function, but we'll get there again later. So the number of tiles from figure to figure increases by 5. So original or starting was 3 tiles, then from there on plus 5, plus 5, plus 5, plus 5. So that's very important. So to describe the graph of this function, that is the visual of how does it look like. So it looks like a line that grows, and it starts at 0, 3, and it has this consistent growth. So let's come up with a nice sentence to describe the graph and put all the details in it. So the graph follows a straight increasing line. increasing because it goes up. Starting at point 0.03, which is called y-intercept. And has the slope, which is the ratio of vertical to horizontal distance. So the tiles per figure, 5 tiles per 1. So slope is the ratio five over 1, which represents tiles, the number of tiles per figure. So the graph follows a straight increasing line starting at 0.03 and has the slope of 5 over 1. In other words, 5 tiles per 1 figure. Then the equation. Every single figure is increased by 5 tiles. So I'm going to use a sticky note to model an equation. So y in my function, or the function of the figure number, is going to start with 3. That's how we started. But then for every additional figure, we added 5. So the next figure, the figure that called 1, was 3 plus 5 and 5 more. Okay, and then the next figure was 3 plus 5 and then plus 5 and then plus 5. So for every additional figure, we are adding another 5. The 3 was the y-intercept, so that is the common starting point. But then for every figure, it's like 5 and then 5 times 2 and then 5 times 3 and then 5 times 4. So the additional 5 from the pattern is the multiplier by the figure number. So my function for any figure will be 3 plus the growth multiplied by the figure number. In slope-intercept form, y equals mx plus b, that is y equals 5x plus 3. So I can write that equation as y equals 5x plus 3. So every figure, and we'll test that, every figure can be calculated the number of tiles using this equation. So for instance, again, testing this equation. So y0, figure number 0, is going to be 3 plus 5 times 0, replacing that function of 0 with the value of 0. And that is 3 plus 0, which is 3. So the figure 0 had 3 tiles. Y1 is 3 plus 5 multiplied by that x, which is the figure number. Following the order of operations, here is 5 plus 3 is 8. So figure number 1 had 8 tiles. Let's see figure number 2. 3 plus 5 times 2. That's 10 plus 3, which is 13. So figure number 2 has 13 tiles. That works. So testing my equation to make sure it works for every figure. figure number 3. And y is, again, based on my graph notation, is the number of tiles that I'm going to have. So the number of tiles in figure number 3 is calculated by 3 starting point plus 5 multiplied by the figure number, which is 15 plus 3, which is 18. And that works. So one figure number 4 can be calculated. It's the number from the beginning, 3 plus 5 multiplied by the figure 4. 20 plus 3 is 23. So why do we need this? Because the question essentially can be, what if I ask you, how many tiles will be in figure 100? Then having that equation, you say, okay, that is going to be 3 plus 5 times 100, which is 500 plus 3, 503. So having the equation that works to figure out how many tiles is in each figure using the pattern, you can answer any figure how many tiles would it be made of.